hopefully we'll be able to shed a little bit of light on what you can do with Docker containers in the .NET ecosystem. And a few minutes ago, I realized that I made a classic mistake. I forgot to find any humor to bring in, so I apologize. A good presentation should always have some humor. We might not be able to find it here. Uh, I'll try to keep it from getting too dry, though. I do have a lot of content to cover, so there are some places where I'll probably go a little bit fast, just being mindful of the time. But of course, you'll have access to the slide deck afterwards to look at any of the details in a little bit more detail. Yeah, so about me, Stephen Fuqua. Fuqua is how you pronounce it, Director of Software Engineering at the EdFi Alliance, which is a program of the Michael and Susan Dell Foundation. And I want to put in a little bit of plug at Vi Alliance. So we work on uniting educators and technology providers to ensure K-12 systems produce useful insights that support student success. And we do that by giving away a lot of software. So I'm able to show a lot of code today because it's open source. We also are hiring at the foundation, not on my team in specific, but we do have a role for a .NET senior software engineer and for a solutions architect. Just love to get a few more applications in there. So where are we going to go today with this, a quick overview of containers in Docker world, a couple of little case studies showing containers in action, and then I want to talk about the software development lifecycle for containerizing your applications, and I'll have a sample application that I created just for this occasion. And so we'll go through many different steps on software development lifecycle. There's an awful lot that we can't cover today. I'm not going to talk about the architecture of containers like Docker, Run C, Containerd, if you've ever heard of any of these things. I'm not going to talk about how uh, these tools actually work. I'm not going to talk about microservice architecture, which containers are a great way to orchestrate many microservices together, but we just don't have time to cover that here. Deploying, yeah, I'm not going to get into any real details on deploying. Again, there's not time, and I admit I'm not an expert on that. Uh, Migrating to distroless or chiseled images, you might hear about those. Sometimes those are more secure images. We're not going to have time for that. CI/CD pipelines, really, for me, the key on CI/CD pipelines, very important, but you just need to understand what the local commands are and then go figure out how to apply those out in GitLab, GitHub, Azure DevOps, whatever you're using. Same, Docker push is how you distribute images. We're not going to cover that. Logging and monitoring, resource allocation, and performance, a lot of really important topics, but well, there's only so much time. So let's jump in. Why are we talking about Docker? Well, one of the reasons, just plainly why we're talking about it now, setting aside the details of the technology, it is in the Stack Overflow survey from last year, the most admired tool amongst other build tools and the most desired. The most desired implies to me that there are still a lot of people who are interested in Docker but don't know how to use it. That's why I'm trying to give some ideas and give some inspiration here for how you can move from zero to uh, you know productive pretty quickly and move out of that desired to actual use. So some use cases. Have you ever had the experience of saying it works on my machine? Most of us probably have. Been frustrated at lack of SQL or other installations on a new machine. I needed to build a legacy app but lacked the SDK. Wanted to move quickly and efficiently to the cloud. Discovered bugs late because test environment didn't look enough like prod. All reasons to think about containers. How did I get two slides? That's weird. Okay, so let's talk about what a container is. Jumped forward a little too quickly. So a container is a standardized unit of software that in theory can run anywhere. Docker talks about the containers being independent, isolated and secure, small, remixable. The independent meaning that you want to design applications with kind of loose coupling between them. I like this app one, app two, app in. So that's where it kind of favors the microservice architecture, being really important here. Isolated and secure, meaning that each of these applications, they're actually going to be running in very secure fashion within the operating system because of the container environment. So that, somebody being able to break into one, just there's no way for them being able to escalate privileges over in another application. Containers should be small, kind of, do one thing. Uh, and they should be remixable that you could deploy multiple instances and using different novel combinations. So within your hardware and software world, you have your kind of your bare metal. You've got a host operating system, whether it's Linux, Mac, Windows, and then you've got your container service, which could be Docker, Podman, Containerd. There are actually a number of different container services now. And then within that container service, finally, you get a virtual network that brings together the different running containers. So that is a basic overview of where the containers sit within a running computer. Then an individual container, it's actually starts out as an image. An image is made up of different layers. You build that image, running the build command on a Docker file builds you an image. That's just waiting. Nothing's happening until you actually run it. Then it becomes a container. So just wanting to give some familiarity with the terminology here. So let's look at a quick case study. So at the EdFi Alliance, we produce an HTTP API that supports exchange of data between different vendors in school district settings. So we're building a new version of our API today that has a number of different components on it. So we've got our main data management service. We've got a configuration service. There's a database behind it. We're doing change data capture through Debezium to write data from Postgres out to Kafka. And then we've got an OpenSearch connector that writes that Kafka stream out to OpenSearch. Of course, we might want to have a dashboard on OpenSearch. Oh, we need identity provisioning. We use Keycloak for identity. All of these tools. It's a lot to be trying to install on your system. A lot of configuration to manage. So we've got it set up where one PowerShell command starts up these tools, and you get all, within about a minute or less, maybe less, all of those services are running within your Docker environment, or in this case, Podman is an alternative to Docker Desktop. Many people might not know about it yet. But this is a screenshot from Podman showing all of those services running. So imagine just going out and trying to figure out how to do a Kafka installation directly on your operating system. Going out and doing the Postgres installation. You don't have to worry about that. Those things take time. This just spins right up. Huge productivity benefit. We also have the system that I was just showing you is replacing this one, the EdFi ODS API, and we can see in this architecture diagram something where you get a system that can be running locally that looks more like a production type system where we've got a web server sitting in front of our applications using Nginx in this case. We've got PG Bouncer, which is a Postgres connection pooling tool sitting in front of our databases. And so again, these are all the tools that can, and more that you can quickly spin up in Docker containers. Okay, another little case study, legacy.NET development. So here I went in, checked out a very old version of one of our applications. It's on .NET Core 3.1. Started up the oops, let's not do that. Started up the .NET Core SDK in a Docker image. Then I'm at a bash prompt I'm able to switch to a directory and just run .NET build, and they'll just have to take my word for it. The build succeeds. I didn't need to install SDK 3.1 on my local host, just able to run the build inside the container. So with .NET Core, .NET 5 Plus, those base images, very useful. You can choose to be in PowerShell or Bash. You can run any .NET command, test, publish, build, etc. Few tips of you can, when you're setting that up, you can do something called mounting a local volume. So you see that here with the -v command. And again, I'm going quickly through this, but you'll have the slides. You'll see everything. Docker run. I'll go ahead and explain this one real quickly. Docker run in interactive mode. Remove the container when you're done with it. Mount a volume so your local application folder gets mounted into a remote folder with read-write access. And there's the container that you're running. I should have explained that the first time. So you want to be able to mount that local volume. You can, create whatever scripts you want within there for build, test, etc. You might want to mount a volume for logs. Just if you do have PowerShell and you've got any hard-coded backslashes, you may want to think about forward slashes. PowerShell will translate a lot of those for you, but not everything. You can also, to some extent, build .NET 4 applications. For that, you're going to want to run Mono. If for those who aren't familiar with Mono, it was a project many years ago to recreate .NET in a Linux environment. Microsoft ended up buying them, and the code for Mono significantly contributed to the development of .NET Core. So this is very solid code base. You can run NuGet restore, you can run MS build. In this specific case, the build ends up failing even after a little bit of cleanup. So it's not foolproof here. It just depends on the complexity of your project. Trying to remember why the build failed. I think there was some the build failed. The build succeeded, but the run failed because it was missing one of the encryption providers used by the old ASP.NET. That's it right there. The deep happy cryptography was missing. And there were also some missing web application build targets that I had to work around to even get it to build successfully. But there's still a lot that you can do with legacy development. Not going to show, but there are different ways that you can actually integrate your IDE into that running container in order to do debugging. So again, you can have the SDK inside of container, and you can actually do some productive work right on your local host. So that was just a couple of case studies that hopefully gave you some sense of where you can go with a full containerized environment. Let's talk about the SDLC. So getting started, of course, you need to install. There are a few other tools. I recommend either going directly to Docker Desktop or to Podman. Podman is fully open source. It's daemonless, which means you're not running a service. It's rootless. I've also found that it's a little bit more flaky in my experience. I've actually kind of gave up on Podman because it just I ended up in weird crash situations a few times that I've not seen in Docker Desktop in years. But I've got an open source subscription, basically, or a verified open source uh, producer. So I've been able to take advantage of that in terms of being able to log in to Docker Desktop that is not available to everyone. So Podman's probably a very good alternative, and I may have just been stressing it out with some of the testing I was doing. If you have both, you need a command like this in PowerShell in order to be able to run Docker instead of running Podman. You can actually run the Docker CLI and it will target Podman when you've got this environment variable set. Okay, so what's our objective with this SDLC? I wanted to build a little sample of an ASP.NET API with a React front end and just demonstrate some aspects of the SDLC. The code is all out there at this repository, and this is where we started out. I just had a very basic uh, repository with API and web as two different projects and no Docker in here. So our very simple sample system architecture, of course, end user interacts with the Node.js website, which is going to be implicitly reading from the API. If you notice the weird little thing in the upper right corner, that is Mermaid.js. If anybody who grabs the slide deck wants to play around with C4 diagrams in Mermaid, you're able to grab the code right there. Okay, so now let's create and build Docker environment. And Docker init is a very helpful command. I'm not sure when they added this. I only discovered it very recently. And we're able to Docker init will go in and it will read what you have in your project directory. It'll auto detect, oh, you've got a package.json. It's a Node project. You've got a CS project. It's a .NET project. And it will set up a lot of boilerplate for you, setting up creating a Docker file, a Docker ignore file. It creates a Docker compose file, which I ended up combining. We'll talk about Docker compose more in a moment, but I combined the two into a single compose file. So Docker Compose is an orchestration tool that allows you to quickly start up multiple containers together. I think I saw that there was something in the chat, and I just wanted, it's hard to see the chat when you're presenting, and I wanted to stop and see if there's anything that, any questions that should be addressed right now. Daniel, can you help me out there?
Yeah, you can throw mermaid diagrams in GitHub and actually pan and zoom in them in GitHub.
Right.
So it's pretty cool.
Yeah, that is a really nice tool, and uh, kind of ran out of time in my case. Get those all in. Uh, okay, so let's look at the Docker file. The Docker file is your build statement, and here, this is the auto-generated Docker file. Uh, I stripped out a bunch of comments explaining it, but otherwise, this is exactly as was created by the Docker init command. What do we have here? I talked about very briefly earlier how an image, so this is going to create an image, is composed of layers. And so we actually see every command ends up creating a layer, or every command that modifies the application. Every time you have a from statement, you actually create a cacheable layer. So this is called a multi-stage build because you first have the SDK here. It does some work. You go in, this is a really nice kind of newer command, uh, mapping out a local cache for your NuGet package directory. And then it runs the .NET publish out here. Then you transfer that into a runtime stage that's just the ASP.NET runtime without the SDK, so that you end up having a much smaller image. Small images are good because they transfer between systems more quickly, use fewer resources at runtime, and a small image probably has a lower attack surface in terms of different uh, problems that could go, vulnerabilities that you could have and dependencies that could uh, give attackers an edge. So you run the build in one stage, you copy the result out to the next stage of the runtime, and then just run the application. Pretty simple. And here is a little bit more complex on the node side, but again, you have a build stage. Here, the Docker init did something more clever that with the template. It created a first a base layer where it restored all the package dependencies in this base layer, and then created the build stage. And what this does is each time, as I said, each time you do a from statement, you have that layer ends up being cached. So let's say that you change some of, in this case, React, your Node.js build process, you change some of the React source code, but you didn't change any dependencies. Well, this layer does not have to be rebuilt. You can, when you run the Docker build command, it just starts from the next command because it'll see that nothing changed up here. So that's very convenient. Run the Docker build, and then you have your final stage where it sets up and runs the React application. Again, this is the boilerplate as we started out with Docker in it. It's actually not exactly correct in this case. I had to change it so the last command runs run preview dash dash and with this really important dash dash host because it's a Vite based Node.js project. But ultimately, when you're running in a container, in this case React, it's not a backend, it's just a React front end. There's really no reason to run Node.js. You can just run a static web server. So you keep your build layer uh, in the Docker file, but then you add a runtime layer based on another web server. For example, my favorite, Nginx, could be Apache. I'm sure there are many other good HTTP servers. So let's show that real quickly. Nginx is a great web server. Uh, you could go out to hub.docker.com to find all of the different versions that you can run. They've got something you'll find very commonly when using third-party images is they'll have many different builds, not just of their own version, but on different operating systems. So you might have one built on an Ubuntu version of Linux, might have one built on Alpine. Alpine is very small, has very few vulnerabilities. You still get some occasionally, but it minimizes compared to using other Linux distributions. So that's what I chose. And so I just went in and I added at the runtime, start up Nginx, copy the dist directory that was built by the npm run build command previously, copy a configuration file for Nginx in, and that will launch the web server. That's what the configuration looks like. It's very simple. So now we've got a system architecture that looks like this. End user is, this is actually a deployment diagram. They're coming into the container service. Inside the container service, you have this network that's for Docker, what I call Docker IRL, and that's where you've got the static web server and an API server that this user is going to be interacting with. Okay, so one of the fun things to do is to think about putting a reverse proxy in front of ASP.NET. I said that one of the advantages of using Docker is getting closer to a production-like environment. Hopefully in production, we're not running the Kestrel web server with direct internet access where people are hitting that. We really want to have some kind of web server or API gateway sitting in front of it, uh, protect it from that internet traffic. Although you can, of course, do secure TLS termination in Kestrel and .NET, and you can do robust rate limiting. It's even better to use an external tool that's purpose built. You can also, in your configurations, when you're bringing together the full network, I've shown Docker Compose, but we'll talk about Kubernetes later. Simplify your port configurations by having a web server sitting in front of your .NET application. So you want to, the easiest thing to do, maybe a little bit controversial, disable HTTPS inside of the Docker network. So on your ASP.NET, go ahead and disable it. I did suggest throw that behind a flag in your app settings though. And you want to be able to change the base path because you're going to need to run at something like /API instead of just running kind of at your base path there. Uh, two quick modifications, and then over in an Nginx template, you can set up reverse proxying so that anything coming in at that path will be passed into the API host. And here you see uh, variable substitution. The Nginx natively supports this variable substitution. These values will be pulled from an environment variable at startup of the container. And so then Docker Compose, which we haven't seen yet, uh, that Docker Compose file will need to be modified. So here's what we have. Docker Compose, again, local orchestration tool. It doesn't really help you get out to the cloud, unfortunately. Nobody has commands that just let you run Docker Compose directly in Azure, Google, AWS. Azure did for a couple of years, but they retired it. But it is a fantastic tool for quickly getting up and running locally. So you define a couple of services. You have your API service, your web service. You give it a build context that's going to auto build your Docker file for you. Container name, you set up some environment variables that are going to inject into here. In this case, we're taking advantage on the API side of the fact that .NET, when you set up reading from an app settings file by default, unless you turn it off, you have access to overwriting your app settings files with environment variables. So we just want to insert that in. That base path is the same as this virtual name down here. This API host is the same as the container name so that they link together. And then you define what was the port that you're using over in the API container, and this is just the default ASP.NET Core port. That's the default value when you're running inside of an ASP.NET container. And then you map some ports externally. So this is port 80 inside of Nginx, gets mapped kind of a random number to 4173 on the local host. So now we have the end user is only interacting directly with the static web server Nginx, which is then forwarding all the calls for the API over to the Kestrel-based server that's actively running. Okay, so we've got a good build environment. Now we can talk about doing a little bit of style cleanup, a little bit of test. So linting, I think in the C# world, we don't often talk about linting tools, but hopefully many people have experienced them over in the NPM world or perhaps in Python. Uh, just a little shout out. I really love the Sonar source Sonar lint for C#. Basically provides a linter that it's not a separate tool that you build right into your CS proj, and you can tune a lot of style settings with Sonar lint. I think they changed the name recently, but you'll still find it under Sonar lint. Okay, so two tools that you can use to check your Docker files. If you have Docker, not Podman, you can run docker build -- check. In this case, it complained that we had lowercase as instead of uppercase in a couple from statements. It's kind of a trivial thing, but okay, for consistency, we can fix that. Hadolint is really the standard open source project for running lint on your Docker files. In this case, I'm showing streaming the Docker file into a running container so that I didn't have to download and install Hadolint. So it's another interesting use case for Docker containers is being able to run utilities. This actually did not complain about the as, but it did complain of something about this target arch was in the default Docker file, and it complained that this string replacement would not work. So thought that was kind of interesting. Yeah, it won't work. I think that this when Docker init with the template, it was just trying to give an idea of what values are available. Okay, then the Docker Compose file. There's actually a really nice linter called dclint out there for a Docker Compose file. It found a few things that were, I won't go into a whole lot of detail right now, but it found some good suggestions for how to clean that up. So that's a little bit of linting on Dockerfile and Docker Compose. What about unit testing? Oh, I did have a slide here. So yes, good advice on the DC lint, but let's just move through. Unit test. Unit test might be a little bit overkill, in my personal opinion. I am a huge proponent of unit testing your code and test automation. Uh, but using a framework to unit test a Docker image uh, feels to me like it's a little overboard, and I haven't really tried it. Here are a couple different projects that you can use. I advocate just running your system test within the container. You'll know everything's working. I'm going to pause. Maybe there's a question or two that see if there's anything to come up. Let's see. Uh, oh yes, editor config is also a fantastic tool. C sharpier. I can't even pronounce that right now. Also a fantastic tool. Glad somebody suggested those. They work together. The editor config works together really well with that Sonar lint tool that I mentioned. Okay, so let's talk about debugging. Take advantage when you need to debug a Docker file, take advantage of the different layers. And I showed earlier that we had a build layer and there was kind of a runtime layer. Uh, you can go in, you've got a problem, just kind of stop at the runtime layer, comment things out up to the point where everything is working, and then you can just run the container, enter into it, and start trying things. You just run commands inside of that temporary container. You can run .NET command, you can run .NET build, .NET run, etc. to help debug what's going on inside of the container. And there are some experimental features for debug commands. I actually have not had any success using these to find anything. So I don't know what they're going to do, but you might find them useful in some cases. Okay, so interesting. Somebody mentions, Daniel mentions Copilot over in the chat, and I wanted to find out what happens when we take our Docker files over to our AI coding friends, coding assistants. So GitHub Copilot, it had one recommendation for optimizing the file. It said set base path using ASP.NET Core underscore path base. I was like, huh, I haven't heard of that one before. I looked it up and I found a Stack Overflow post and a random GitHub discussion that mentioned this environment variable. And I looked at the official list of environment variables. It's not in the list. I also looked out in the source code for ASP.NET. This environment variable does not exist in the source code. I tested and confirmed this does not work. So GitHub Copilot, it gave me a suggestion based off of these two sources that was kind of irrelevant without a whole lot of other context in them. So in this case, by the way, I've absolutely loved GitHub Copilot as I've been getting used to it. In this case, it gave a false lead. It wasn't completely hallucinating it, it just didn't give the context that would have made this useful. Amazon Q actually had a lot of good suggestions on the other hand. Uh, it gave, I'm not going to run through these in full detail, but every single one of these is relevant. Uh, the no restore on number 3 was a good suggestion, but actually ended up causing a little bit of a problem. I had to back it off. It's the type of thing, go apply them one at a time, make sure that your code still works, back out when something's wrong. The health check, that's a really interesting one. I wanted to zoom in on this health check that was suggested by Amazon Q. So the orchestration tools like Docker Compose or Kubernetes and OpenShift, all these different tools, uh, they will monitor, is your application up and running? you have to define what healthy up and running looks like. So we can add a health check over in the web server. In Nginx, we can just simply add an endpoint called health that statically returns the word healthy as plain text.
Hmm.
Over in the Docker file, set it up to run a curl command. Curl, when it finds this, when it finds a 200, everything's fine, it's good. But if it finds anything from status code 400 or above, then that curl command will fail and the health check will actually return unhealthy. Oftentimes what your orchestration tools can do, especially when you start moving over to Kubernetes, it will actually see unhealthy containers and it will stop an unhealthy container. Well, first it will start a healthy one, it will stop an unhealthy one and try to automate getting you back up and running quickly. On the API side, ASP.NET has some built-in health check capability. Couple of commands here in your program.cs gets a health endpoint running. They come into your Docker file. We need to get a little bit better here. The Alpine distribution of the ASP.NET runtime comes with wget, which is a standard Linux utility for accessing files over HTTP, files or APIs. It does not have the same failure response as curl, the other common application that you find. And curl is missing. So curl is a better tool for a health check, but you have to install it when you're using the Alpine-based image for ASP.NET. You have to switch them out. So delete the wget, install curl, run your health check. So now when we come to our deployment diagram, inside of the container service, there's some internal monitoring. I don't know what it's called. I looked, couldn't find a name, but every container service is going to have some internal monitoring that goes out and checks those /health endpoints. Okay, so another optimization that was mentioned by Amazon Q was to pin the digest. So what does that mean? If we look at this line, commented out line in green, that this was the original. It said run SDK 8.0 on Alpine, and that could change. So there's 8.0.2, there's 8.0 point, or actually it's 3.20, and there's 3.21, which I think is an unstable. Odd numbers on Alpine, if I remember correctly, are unstable. Well, you don't know precisely which image you're actually running from. So if you uh, want greater consistency everywhere, you need to know precisely which image and make sure it's the same image being run on your computer, the next person's computer, out on your remote hosting. And that's where you do this pinning with the @ SHA-256 and a digest number. Go out to Docker Hub, or from Microsoft, you look at the Microsoft Artifact Registry, and there you can find the SHA-256 digest. One of the things when you run Docker pull, it will also show the index digest, or it will show, not index, wrong word, it will show the digest of that image. But there's this concept called index digests that, remember earlier, I didn't actually spend time on it, so you might not remember. I said something about target arch, target architecture was a variable. Of course, you can build for Linux running on AMD 64, or x64 uh, CPU, or you could be running a build that is targeted to ARM 64. And when you use the digest shown by Docker pull, then you're going to get your architecture specific digest. But this index digest that you find on Docker Hub or the Microsoft Artifact Registry gives you an architecture independent digest. So this will allow the hosting service to pull the right architecture. Okay, so now let's quickly go through. See, we're at 12:45. I need to run through this, but we're getting pretty close to the end. Of course, you're probably going to want a database layer in there. You want to throw into your system inside that container network. container service inside your specific network, some DB, maybe running MS SQL, Postgres, etc. Once you have a database in there, you're going to want to modify your ASP.NET health check. Go look at this link. Won't get in a whole lot of details. It shows you nicely how to have your health check in your .NET application actually checking the database health, making sure you have a good connection to the database before reporting that you're healthy. When you run this, you must, if you're using the Alpine-based images as I was, you must manually add in globalization support. This link tells you how. So after I added all this code, I've got the health check. MS SQL is not running. It just reports unhealthy as desired. As soon as I turn it on, it's going to come back that this command to the health endpoint will say healthy. Without getting into a whole lot of details, you can add into your Docker Compose file, startup of the MS SQL image. You need to accept the license. You need to give it a password. Here's a standard health check for Docker going directly to the SQL service to check on it. You want to map a volume. So something to learn about in more detail elsewhere. You you need some permanent storage for your SQL server because as soon as your container, when you run it, as soon as you stop it, everything in there is going to get lost unless you have uh, a volume mounted where you're saving onto the host for Docker. But then in this case, I also needed to inject a proper connection string into the settings for the API. So nice long string, connection strings under double underscore default connection. That gives us an environment variable that will override that connection string. So now we have internal monitoring can access all three of these services. The API server also is doing health check against the MS SQL database, and we're getting a little more complex, getting a little bit more real world. Let's talk about security. So software development lifecycle security really, of course, needs to be in all stages. I don't mean to suggest this is an afterthought, just needed to go through thinking sequentially. So review your files. Make sure that you've limited scope of port mappings. I breezed through that very quickly. You have to make your ports available from within Docker to the external host, and you want to limit that. For instance, you don't want internet traffic to be able to hit your SQL server. You want to protect it inside of that Docker network. Use environment variables or cloud secret manager like Azure Key Vault to inject secure settings instead of having them written directly into your files. And I'm going to show you that in a moment. Make sure you're running as a non-root user. And you can also go through and look at this OWASP cheat sheet for some more tips on securing your runtime Docker environment. So environment variables, those of you who have done any JavaScript, TypeScript, you've probably seen environment variables. Don't use them, or a .env file is what I mean to say. We don't see those in the .NET world, but basically it's like your local user settings. So here at the top, we have the Docker Compose file, where I'm using this variable substitution format to pass a value in. So this Docker Compose file, of course, is kept in, you keep that in your source control, and it doesn't have any secure values. Your .env file that I show below, it has your password in it, right? You don't put that in your source control. You just keep that locally. And you can also do some other things if you wanted, in different environments, you might want a different health check command. So you can extract that out into the env file. You also have within here, you have variables that can be interpreted in. So you write down the password once if you need it in multiple places, and you can use it in the next environment variable. Very useful there. Okay. You also have to watch out for insecure OS dependencies. Uh, the operating system and its packages could have vulnerabilities. Alpine helps minimize them, and you need to Be really careful though when you're installing extra things. Take them out. If you need to install zip to unzip, let's say a NuGet package, then remove it again. There's .NET. Microsoft has created something called the chiseled images that are even smaller in Alpine. I haven't experimented with them yet, so I'm not going to see them here today. There's also a concept called distroless that you can look up. There are some nice scanners that help you look for vulnerabilities to automate this process. Docker Scout, that's one. Trivy is open source. Gripe is open source. They all find slightly different vulnerabilities in the web project. So this is looking at that Nginx uh, layer that I had. There is some vulnerabilities in here that I would need before going to production. I'd want to look really closely to see if this would actually expose my system to any danger. Deploy, and this is the last section, so we're doing okay on time. I'm not going to talk about this in a whole lot of detail. I wanted to talk about how to get you up and running. Docker Compose, fantastic locally. Docker also has this thing called Docker Swarm. I've never personally seen it in use. It's more for an on-prem data center. Kubernetes is really your gold standard at this point. It's an orchestration platform that takes the concepts that you use in Docker Compose, applies them in an even more robust fashion with auto scaling, better configuration management, and you can run Kubernetes locally and take your same Kubernetes configuration, and you can run it in managed Kubernetes or K8s services out in the cloud. Your cloud environments also have their own proprietary cloud formats with AWS Fargate, Azure Container Instances, or Google Cloud Run, where you can run serverless for containers. Some challenges I found with Kubernetes, it's conceptually really amazing, especially for microservices, but there is a lot more that you have to learn on top of the basic Docker commands. Uh, Run into things called pods, sidecars, kubelet. Your networking is different. Uh, I've also found that the local host tooling in Windows is kind of flaky in my experience. Moving to Kubernetes does help you reduce some vendor lock-in, but even still, every time you want to deploy out to a different cloud environment, each host is still going to deploy the Kubernetes a little bit differently. So it's not 100% universal, but it's getting a lot closer to universal. There is a nice tool called Compose that will convert your Docker Compose files, Compose with a K, over to Kubernetes or to OpenShift, which is another platform that I haven't talked about. I tried running that on my sample. It got close. I'm not a Kubernetes expert. I didn't get it working. That's the limit of my capabilities here. So Kubernetes, a whole nother thing for somebody else to present about in more detail. With that, I have just rushed through helping you see hopefully some of the advantages of being able to use Docker containers, how to incorporate uh, them into your software development lifecycle, and hopefully be a little bit more productive as a .NET developer. Thank you for your time. And let's see if in these last few minutes we've got any other questions that we can address here. Looking at my other monitor, scrolling through the chat to see if there's anything else.
I'll say I'm curious. I'm a big fan of test containers. Have you heard of that library? I'm
Yeah,
just curious
test
if you've used it,
containers.
your opinion on it. Yeah.
Uh, I think test containers are really powerful. So what you can do is you can, for everyone else, if I can state this correctly, test containers framework you can incorporate directly into your MS test or DS test, whatever they're calling it nowadays, your C Sharp project. You can launch at startup of your system test, launch all these different container services. You can compose that in C Sharp code, or they've got test containers for Python, test containers for JavaScript, for Java, all these other frameworks. Great tool. We used that for a time in our data management service that I showed early on. We were having some success with it until we had a step where we had to inject some runtime settings that it was getting to be a problem figuring out how to get the timing right within test containers, and we had it all worked out in Docker Compose. So we actually abandoned test containers in our case. I really liked it. It just kind of was failing our test case. So instead, we just ran Docker Compose up, ran all of our tests, Docker Compose down.
Cool. Thanks.
Glad you brought that up, though. Okay. Anything else? Great. Well, thanks again for your time. Look forward to seeing what we have in the users group next month and appreciate the opportunity.